Okay, so let's look at a collision. The first thing that we want to look at is what type of collision, what is actually happening. Okay, in this situation, you have two objects colliding and then they're bouncing off of each other. Right there, you know you have a decision between elastic and inelastic. It is not a perfectly inelastic because they do not stick together. Most likely, this is going to be an inelastic collision, but we really wouldn't know unless we determined if the kinetic energy was conserved or not. We know, however, that all of the momentum, no matter what type of collision, is going to be conserved from before collision of the system to after collision of the system. Okay, so first thing let's do is find the momentum of each object, 1 and 2, before collision. So the initial mass and velocity, 4 kilograms, object 1, times positive 10 meters per second. And that gives us positive 40 kilogram meters per second. That's the initial momentum of object 1. The initial momentum of object 2, we use object 2's mass and its initial velocity, 18 kilograms times negative 4 meters per second. Please remember that direction is important. We are talking about vectors here. Now, if I were looking at this and I said, which object has more momentum? Please make sure you understand momentum is not based on its positive or negative. That's the direction. So when I ask for more momentum, we're looking at the magnitude of the object. And that would be object 2. So after collision, we know that the object with more momentum is going to lose momentum, and the object with lower momentum is going to gain momentum. So object 2 is going to lose momentum, and object 1 is going to gain momentum. We should be able to see that to be true when we do our math. So let's find the momentum of object 1 after collision. Remember, object 1, the mass does not change. All we're doing is changing its velocity. Okay, we said that object 1 is going to gain momentum. We found it to be 44 after collision, so it did gain. We said object 2 is going to lose momentum. So now we need to calculate that. How am I going to calculate the final velocity of object 2? Well, we know since the momentum must be conserved, we can set the before equal to the after. Before collision, and then after. And we already have these numbers, so we can just plug them in. And then for the final, we're just going to use 18 times V2F. Now we can simplify and solve. Simplify the left. And then combine like terms by adding 44 to both sides. And then divide. We're going to round in this case so we can have 2 digits. And we should get a positive number. If we look back at our original picture, our object is going to the right, so that is good. And now we can calculate our final momentum. And we get approximately 12. Okay, and that is a loss.